In the early 20th century, people used galvanized steel cone-shaped fire buckets. These buckets were hung on a wall which were filled with sand inside, and they were used in case of fire breakouts. But gradually, people realized these buckets were not really useful because these kinds of buckets could not be kept on the ground as the sand would fall off if it is kept on the ground. So, they started using another kinds of fire buckets which can be kept on the ground also. These fire buckets are widely used nowadays. Now, if you observe the shape of fire buckets, their shape is not exactly a cone. This can be reduced to make a cone. That means they actually come out from a cone, and this shape is called a frustum. Let's see now what exactly a frustum is and how are they formed. When a cone is sliced with a plane parallel to its base, two separated parts of the cone are formed. Now remove the cone that is formed on one side of the plane and the part that is now left over on the other side of the plane is called the frustum of the cone. Frustum is a Latin word meaning piece cut off. Let's discuss some more examples of a frustum which we see around us. Glass tumblers. In general, it is used for drinking water are of this shape. Some electric lampshades are also an example of a frustum. Metallic buckets which we use for pulley to draw water from well also falls under this category of examples. Let's now discuss the volume of the frustum of a cone. What is the volume of the frustum? As we can see, frustum is a combination of solids. It is the bottom portion of the truncated cone. Volume of frustum is equal to volume of the larger cone minus volume of the smaller cone. Let h be the height, L be the slant height, and R1 and R2 are the radii of the ends of the frustum of a cone. Also, R1 should be greater than R2. Then we can directly find the volume, curved surface area and the total surface area of the frustum using the formula. Curved surface area is given by pi into R1 plus R2 into L, while the total surface area is given by pi into R1 plus R2 into L plus pi into R1 square plus pi into R2 square, and the volume is given by 1 by 3 pi into h into R1 square plus R2 square plus R1 into R2, where L is equal to slant height and the L is given by the equation square root of h square plus R1 minus R2 the whole square. Using the formulae for finding volume, let's go through one example. A drinking glass is in the shape of a frustum of a cone of height 14 cm. The diameters of its two circular ends are 4 cm and 2 cm. Find the capacity of the glass. Let's see the solution. Since glass is in the shape of frustum, capacity of glass is equal to volume of the frustum, which is given by the equation 1 by 3 pi into h into R1 square plus R2 square plus R1 into R2, and the height of the frustum is equal to 14 cm and R1 is equal to diameter of the first circular end by 2, which is equal to 4 by 2 is equal to 2 cm. R2 is equal to diameter of the second circular end by 2, which is equal to 2 by 2 is equal to 1 cm. Now substitute the values in the volume equation and we get 1 by 3 into 22 by 7 into 14 into 2 square plus 1 square plus 2 into 1. Again 1 by 3 into 22 into 2 into 4 plus 1 plus 2, which is equal to 22 into 2 into 7 by 3, and on solving we get 308 by 3, which comes out to be 102.66 centimeter cube. Hence, the volume of the glass is computed and we get the answer as 102.66 centimeter cube. So, let's have a recap of the frustum of a cone. We have seen exactly what a frustum is and how are they formed. When a right circular cone is sliced through by a plane parallel to its base, the resulting solid obtained after removing the smaller conical portion is called the frustum of a cone. And some examples which we have discussed are glass tumblers, lampshade, buckets. Also, the volume of the frustum is the difference between the volume of the larger cone and the volume of the smaller cone. Let's go through the formula involving the frustum of a cone once more. Curved surface area is given by pi into R1 plus R2 into L. Total surface area is given by pi into R1 plus R2 into L plus pi into R1 square plus pi into R2 square, and the volume is given by 1 by 3 pi into H into R1 square plus R2 square plus R1 into R2, where L, the slant height, is given by the equation square root of H square plus R1 minus R2 the whole square. The H, the vertical height of the frustum, and R1 and R2 are the radii of the two bases of the frustum.